Okay, guys, before we can go on to the next lesson, I do need to go over rational exponents with you just to make sure you remember them. So, first of all, a rational exponent is just an exponent that's in fraction form. Recall that the bottom number of the fraction is the root of the fraction, or the root of the number, and the top number of the fraction is the exponent. And so in this first part of the worksheet, all they've asked you to do is to rewrite it. And so we're just going to take it, if it's in exponential form, which it is in the first part, we're going to take exponential form and we're going to rewrite it in radical form. And in the next part, we'll have it in radical form, so we're going to rewrite that in exponential form. All right, and so the very first number I see is 5 to the 1/3. And so I would simply write that as the cube root of 5. And so in order to tell me that you're taking the cube root, you do need to put a 3 there. Otherwise, I'm going to think you're taking the square root. All right, and so we would have the square root of 5 to the first power, which is 5. So you don't have to, show that that's the, fifth power or 1 power. You just leave it alone. Okay, and then number 2, we would be taking the fifth root of 6 squared. Well, 6 squared is 36, so if you want to go ahead and work that out, you can. And so on and so forth. Number 3 would be the 7th root of m to the 4th. Number 4, you have a little bit of work that you need to do. What's the law there for those exponents? Is that a power with another power? What's the law there? I believe it is multiplication. So you're going to need to multiply those two. 3 to the 2/5 is 6 over 5. And so you've got n to the 6/5. All right. And so if you want to rewrite that as a radical, that would be the 5th root of n to the 6th. You're not simplifying. You're just rewriting. Okay. In the next part, it's in radical form. We would just take it, put it in exponential form. So 79 would be to the 1/2. Number 6, 153 would be to the 1/4. Number 7, that would be each individual term. So 27 to the 1/3. M to the 6 over 3, which would be 2. And n to the 4/3. Number 8, that would be 2 to the 1/5, a to the 5th, and b to the 1/5. So all you're doing in that section is rewriting. Okay, so we're down here on the next section where they actually want you to evaluate, and evaluate means you need to get a value, okay? So you might want a calculator at this point. You can use your phone. If you haven't downloaded a calculator, I suggest you do so. So basically we're taking the 4th root of 81. You can rewrite it if you want to. It's probably going to be easier for you to write it in your calculator using the exponent button and putting in a 1/4 than trying to find the 4th power on your calculator. So we're looking for a number that would go to the 4th power and give you 81, which it does exist. It is 3, because 3 to the 4th is 81. The 4th root of 81 is 3. Likewise with 1024, the 5th root of that would be 4, because 4 to the 5th is 1024. We've got 8 to the, 5/3, which means we got to do two things. We got to take the cube root of 8, which is 2, and we got to put that to the 5th power, which will give us 32. So you need to do both of those things. If you'd rather do 8 to the 5th first, you can do that first. You can do 8 to the 5th, then take the cube root. I would rather take the cube root of 8 because that's a smaller number and I know what it is, and take that root, which is 2, and put it to the 5th power, which is 32. So that's up to you. Okay, so 12 and 13 are different. As you can see, they're written differently, and they have different meanings, okay? So in number 12, you actually have a negative that is outside of the parentheses. If you look at 13, it's inside the parentheses. And so basically what you're doing in number 12 is you've got a negative 1 times. Just think of it that way. And so -1 is kind of outside of the exponent. It doesn't have that 3/4 exponent. It's 256 that does have the 3/4 exponent. So we want to take positive 256, and we want to raise it to the 3/4, okay? Which is basically taking the 4th root and then cubing it, all right? And that number is 64. And so if we do it that way, we're going to end up with -64. So you can actually get an answer there, okay? Number 13, they want you to do the same thing, but they want you to use the negative this time. Well, you can take the cube root of a negative. That is legal. You can't take the square root of a negative, but you can take the cube root of a negative, because a negative times a negative times a negative is a negative. So you can take the cube root of -64. It's simply going to be -4, and you can square that, which is going to end up being positive 16. So if you use your calculator on that, I would definitely use a parentheses around the number. In number 14, you're going to use your laws of exponents, which tell you to add exponents when you're multiplying with the same base. So our base is 27. We're going to be able to add 1/3 and 4/3. Well, what's 1/3 plus 4/3? 5/3. So we're going to be able to take 27 to the 5/3. Again, it's up to you. If you want to do 27 to the 5th power, you go right on ahead. I'm going to take the cube root first. So I'm going to do the cube root of 27, which is 3, because 3 times 3 times 3 is 27. And I'm going to take 3 to the 5th power. And that's easier for me to calculate, which is 243. Okay, so it might take you a little bit of work on these to figure them out. On a problem like 15, since it's in parentheses, both of those numbers are getting the exponent 2/3. And if you do 125 to the 2/3, you get 25. And if you do 216 also to the 2/3, you get 36. So keep in mind you do both the numerator and the denominator to the 2/3 exponent. Same thing with number 16. 64 to the 2/3 is 16. And 343 to the 2/3, I believe that's the 2/3, is 49. Okay, so it's the same thing either way you write it. A problem like number 17, again, whoops, sorry. They don't have the same base, so you don't want to add the exponents, okay, like you did above it. You can't add because they don't have the same base. So I would just go ahead and work it out. The square root of 25 is 5. You can figure that out. The cube root of -64 is -4. So I would work them out individually and then multiply, which would give me -20. Okay? All right, so we didn't need too many rules or too many laws of exponents in those problems, but you do at the bottom. You actually do need your laws of exponents at the bottom. So let's just go. I'm not going to do all of these. I'm going to do some of them. They do get a little bit complicated. If some of you want to try them on your own, feel free to. You can always, ask me later, is this right? But if I have a problem like number 18, again, I'm multiplying. We're going to add those exponents. I'd end up with 7/7, which is 1. So I would get g to the first on that. Number 19, if I were to add those, if I can see, it looks like it would be 16/4, and 16 divided by 4 is 4. So don't forget your base, but that would be s to the 4th. Number 20, that rule is not adding. That is multiplying. Okay, see the difference? Number 18, how it's separated. Number 20, how it's side by side. Different rules, okay? You have a power with a power. You want to multiply those. 1 times 4 is 4. 3 times 5 is 15. So I'm going to end up with u to the 4/15. Okay, I really can't see anything I can do on 21. So Let's skip to 23. If I have a problem like that, I can simply subtract. I think that says 3/5 minus 2/5. 3/5 minus 2/5 is 1/5, so I'd end up with q to the 1/5. That was easy enough. Okay, let's do a hard one. We'll finish with this number 24, okay? The negative exponent, now if you recall, a negative exponent just means you're in the wrong location. So what I would do is move that to the numerator. Okay, once you move that to the numerator, it's no longer there, okay? I'm in the numerator now. I have the same base, so I'm going to add. I'm going to add 2/3 to 3/4. So 2/3 plus 3/4. Going to get my fraction there, which is 17/12. So in my numerator right now, I have t to the 17/12. Okay? But I still have 5t to the 1/2 in the denominator. So I still need to reduce because I still have t in the numerator and the denominator. We know they're going to reduce. So what do we do to those exponents at this point? We're going to subtract. Okay? 17/12 minus 1/2. We're going to work it out. We're going to end up with 11/12 as our exponent for t. And it's going to be in the numerator. It's positive. So t to the 11/12 in the numerator, if I can fit it on there, over 5. Okay, so 5 is still in your denominator. And that's pretty much as far as you can go on that, okay? Some of these at the bottom would require you to rationalize the denominator, if you can remember that. So if you want to try those, if you're a little bit advanced, you might want to try those at the bottom. But anyway, I just wanted to go over this with you in a quick amount of time so that you would be able to move on to our next lesson. This is simplifying radicals and rational exponents.